Hello.
Yes.
Yeah, just one doubt. Actually, I from which book we can find questions to solve manually? I mean, for extra questions to solve.
Sorry, I didn't get you.
Yeah,
Can you repeat?
actually I need to solve much more question to get a practice apart from that activity. So out of the two books, which book I need to get it to get most problems to solve and learn about
From
this
from from this week?
from complete statistics 2 point.
Uh, okay. So for like from the starts to part, you already have two books. So you can
Okay.
refer to Sheldon Ross. Sheldon Ross, you can get good practice for these weeks, like
Okay.
joint PMF and all. Everything is there. You can practice. There are a lot of questions. You can practice from there.
Okay, the Sheldon books, the co-authored by three authors, right?
Yeah,
Yeah, okay.
the one
Thank
you
you.
had
Thank you.
referred in stats, the same you can use for the first few weeks. Yeah.
So
Okay.
for second part of the
For
course, we
second
need to.
part, Walpole is like Walpole has good content.
Okay.
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 Yeah. So yeah, I will start the class now.
Excuse me, ma'am.
Yeah.
Ma'am, where can I find the books?
So you can download. It is available online. So the two books that is provided to you on the portal, you can go and download it. Are you aware of Libgen?
No, ma'am.
Okay, so there is a website called LIBGEN.
Okay.
Okay, so you can go there and you can search many books.
Okay, ma'am, but I want to know where from the portal, where in the portal the books
Okay,
are
where in the
mentioned.
portal? Okay.
Yeah.
So you can go to course introduction.
Yeah.
First part. There you will see about the course.
Yeah.
Okay, so there you will see the instructor's name, the professor name, and the content, the book references.
Okay,
Okay,
so
you
ma'am.
can
And ma'am,
get,
these two books I can download from Libgen.
yeah, and even you can check before going to Libgen, you can check online, like just Google it. Okay.
Okay, ma'am. Thank you.
Yeah.
Excuse me.
Yeah.
Ma'am, can you mention the books again? I joined late.
It is there on the portal. We'll come back to it. First, let stick to week
Okay.
5 credit. Okay. So if you have any doubt, yeah.
I just joined the live, and am I supposed to join?
Okay, so yeah, no, I have just started. So you have to go to joinpd.com and type the code NENGOO. You can see on the type right uppermost corner, right? You can type that code.
Which site, ma'am?
Joinpd.com.
Okay, ma'am. All right.
Okay.
Excuse me, ma'am. I have a
Yeah.
question. It's regarding stats and mathematics too, both. So
Can we take this question at the end? Let's not delay. It's already 7:04.
actually, I will not be attending the session for 2 hours or something. So my question is that why do we have separate type of sessions for mathematics and statistics? Because in stats, if I come back to this video after 2 weeks and I can easily understand the concepts, because we have like 10 questions being solved in one session. So I can focus on the question number, pause it, then solve it, and then see the solution. But in mathematics, they do not have this kind of slides. So it's very difficult for a working professional to understand where the question is and where the solution is. And I have to watch 2 hours of session completely to
Okay, so
that thing.
this you can convey to the maths team. You can write it to them on Discourse, and you can convey this.
Okay.
Okay. So
I'll do that. Yeah. Thank you.
Thank you. Yeah. So okay, let's not delay more, and we'll start week 5 solve with us. Please mute who's there.
Excuse me, ma'am.
Yeah.
Ma'am, at the end of the session, are you going to solve our doubts too?
We'll see how much time we are left with. Okay.
Okay, ma'am. Week 6 open session, in that also we can also ask.
You
a
can
doubt.
also ask, yeah. So there are two more sessions apart from this. So you can discuss any doubt from week 1 to 5 in those two sessions. Okay.
Yeah,
So
okay.
let's stick to week 5 credit for now. So, okay. So I can see, all right. So all of you who haven't joined it, please go to joinpd.com and use the code NENGOO to start the class. Okay. So first, so this is our first question. It says the joint PDF of two continuous random variables x and y is given by fxy, where it is defined as for x greater than 0, y greater than 0 as k times e to the power minus x plus y. Otherwise, fxy takes the value 0. So you have to find the value of k. So you can just type your answer there. Okay, please do it first. I have received only 20 responses yet. Okay, so should we move to the solution part?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So first, let's see what all of you have answered. Okay. So somebody has answered -1. Somebody has answered in between 0.5 and 1. Somebody has answered 2. Okay. Okay, so many of you have answered 1 as an answer. So that is correct. Yeah. So in the problem, it was given to us that the joint PDF of 2 random variables is defined as this. Now, how do we find the value of k? So to find the value of k, what we do is we integrate, right? So in this case, we have 2 random variables, x and y. So we'll have to use the double integration. We have to integrate it twice, once with respect to x and then with respect to y. And the range is given to you, x greater than 0 and y greater than 0. So according to the property of PDF, we know that the double integration over the whole support is going to take the value 1. So this property we are going to use to find the value of k. All right. So let's see the solution. So we know that support if you integrate fxy with respect to dx and dy over the support of xy, then it should give you the value 1. So x was defined from 0 to infinity, y was defined from 0 to infinity. So we have mentioned the limit as x varying from 0 to infinity, y varying from 0 to infinity. And our fxy was k times e to the power minus of x plus y dx dy. So first, so k is a constant. So as you know, in case of integration, we can pull the constant term outside. So we can take it outside and then we will be left with e to the power minus x into e to the power minus y dx dy. So first we are integrating with respect to x. Okay. So if you'll integrate with respect to x first, so you will get e to the power minus y minus e to the power minus x, and the range will vary from 0 to infinity. So once you solve it, you will get e to the power minus y, right? So that value between 0 to infinity, that is going to take the value 1. So again, if you solve it, if you look at the right hand side of this page, so you will see it is just e to the power minus y dy, y varying from 0 to infinity and k is outside, and it should integrate to 1. So again, if you solve this part, e to the power minus y dy while varying from 0 to infinity, again you will get the value as 1. So k will come out to be as 1. So I hope it is clear, and I hope you know how to do the integration.
Excuse me, ma'am.
Yeah.
Ma'am, one thing here, ma'am, the support of x and y is from 0 to 1. So,
0
ma'am,
to infinity.
ma'am, in the question it was given x goes from 0 to 1 and y goes from 0 to 1.
No, it's
Okay.
0 greater than 0.
Yeah.
Okay.
Ma'am, one thing here.
Yeah, tell.
Ma'am, in activity question, it was similar like that. We have to calculate the value of c, and ma'am, the limit for x was given from 0 to 1, and y was given from minus x to x. So, ma'am, in this question, what should be the limits we have to take for dx and dy?
Okay, so you're talking about activity. Can you tell me the question number?
Ma'am, question number 9.
What is the which lecture?
Ma'am, activity 5.3, question number 9.
Question number 9.
Ma'am, here y is given between minus x to x. So what limit should we take for y?
Minus x to x.
Okay, the same one.
Yeah.
Okay.
Okay, I have written down the question that you have mentioned. We can see that question again at the end. Is it fine?
Okay. Yeah, okay, ma'am. Thank you.
Yeah. Okay. So any other doubt in this question? No?
Ma'am,
Okay.
will the value of k change when the limits change?
Which value? The k
Ma'am,
value?
the value of x and y. The value of x and y depends on value of k, no, ma'am.
No. See, fxy was given as k into e to the power minus x plus y. Okay. And it was given to us that for x greater than equal to 0 and for y greater than equal to 0, fxy is taking k e to the power minus x plus y. So x greater than equal to 0 means what? X can take the limit from 0 to infinity and y can take the limit from 0 to infinity. Correct? So what is meant by 0 otherwise? It means from x varying from minus infinity to 0 and y varying from minus infinity to 0, fxy is taking the value 0. So in this case, so we have defined fxy as k into e to the power minus x plus y, and we have taken the limit as x varying from 0 to infinity and y varying from 0 to infinity, because that is the support. That is what is support. Support is where your fxy is greater than 0, right? So that is why we have taken the limit as x from 0 to infinity and y from 0 to infinity, and over these limit this integration is going to be 1. So the value of k is depending on the support actually. If your support was different, maybe you will get different value of k. Okay.
Thank you, ma'am. Yes, ma'am.
Yeah.
Madam, one clarification.
Tell.
Suppose it's an exponential term.
Sorry. Can you repeat?
EPT say the f of x is a exponential term. That is a e power minus x.
Okay.
If x tends to minus infinity to plus infinity, then the e power minus infinity always equal to 0. Correct, ma'am?
E to the power minus infinity. Yeah.
0. Then the e power infinity will be equal to infinity.
Yeah, right.
Then we can say that from this point of view, can we say that the limit is from 0 to infinity?
I didn't get your point.
The domain is
said,
minus infinity to plus infinity domain. When you substitute the function, is going to be 0 to infinite.
Okay, so the domain is from 0 to infinity for x or for
minus
y?
Infinity to plus infinity. Domain is minus infinity to plus infinity.
For
the
x,
function is e power minus x.
Both for x and both for y?
Yeah, this is for only function, madam. E power minus x only, I'm saying. E power minus x only. E power x, exponential term.
So you are saying fxy is e to the power minus x.
Yeah, correct. E power x, madam. E power x.
Okay, e to the power x. Okay.
Yeah.
And
then when you substitute minus infinity plus infinity, the domain definitely will be go to the 0 to infinity or infinity. Yeah, as per average 0 to infinity. If you take x plus y, if the x is minus infinity to plus infinity, y is also minus infinity to plus infinity, then the combination we can say that minus infinity to plus infinity. Again, it's going to be 0 to infinity. Is it correct, madam? Assumption?
I'm not getting your point.
Yeah, e power minus x, madam.
Okay.
E power minus x or e power x, whatever it may be.
Okay, e to the power. Let's say I'm taking e to the power x. Okay.
Yeah, now you tell. The domain is minus infinity to plus infinity. What is the function value? What's the range of the function value?
What is the range of e to the power x?
Yeah, yes, madam. The resultant value of x value. That's a range.
So that is 0 to infinity, no?
Yeah, that's why. That's why, madam. So that's why we are taking. If it is exponential term, if it is a domain is equal to minus infinity to plus infinity, the range always will be equal to 0 to infinity because the exponential term never will be negative.
That is correct.
So in the manner, we can say that the support of x comma y is 0 to infinity.
Support of xy is 0 to infinity. Why we are saying support of xy is 0 to infinity? Are you talking about this relation or in general?
General, madam, general. Because e power minus x plus y, this is exponential term. Because f of x is
in that case, it is 0 to infinity.
Yeah, that's right. That's right. Thank you, madam. Thank you.
Okay.
Yeah, I got it.
Yeah. Okay. Thank you. Okay. Let's move to the next question. So, so the PDF here is same as the previous one. So we have already found that case one. So in this case, fxy is defined as for x greater than equal to 0, y greater than equal to 0, it is defined as e to the power minus x plus y, otherwise it is 0. Now what you have to do is you have to find the value of probability x greater than equal to 4 and y less than equal to 4. So this you have to solve. So you have 4 options here. You can choose one of them.
Option B.
You can mark your option there. Please
Yeah, okay.
don't tell. Okay. Okay. So far we have received some 34 responses. Okay. So 33 people have answered option B. 35. All right. Yeah. So option B is correct. So can anyone tell me how did they take the limit?
Ma'am, the limit of x will be 4 to infinity and the limit of y will be 0 to 4.
Yeah, right. So you just have to take care of the limit and do the integration properly and you will get your answer. So, okay, so we'll just quickly go through the solution. So we knew that fxy is e to the power minus x plus y, and x was starting from 0, x greater than equal to 0 and y greater than equal to 0. And we had to find probability x greater than equal to 4, y less than equal to 4. So we'll take the limit of x from 4 to infinity and y from 0 to 4, and we'll integrate our fxy with respect to x and then with respect to y. So once you do the integration, just do the integration properly, do this part properly, and you will get your answer to be e to the power minus 4 into 1 minus e to the power minus 4. Any doubt in this question?
Excuse me, ma'am.
Yeah.
Ma'am, it says y is less than equal to 4.
Huh?
So how do we, I mean, if you say 1 minus e raised to the power minus 4, wouldn't it be y less than 4 and not less than equal to 4?
We are saying y less than equal to 4. Then?
No, okay. So what if it's y less than, just less than 4? What would the equation be?
It will again be same because x and y are continuous random variables. Correct. It is not discrete. It is a continuous random variable. So again, the limit is going to be the same.
Okay, ma'am. Thank you.
Okay.
Ma'am, I have a doubt in this.
Now,
Probability x greater than equals to 4. For x, my limit will be from 4 to infinity, correct? And,
yeah, correct.
And less than equals to 4, the limit will be minus infinity to 4.
Right. So, but yeah, so there you are going wrong. So it is given to you that support of xy is greater than x greater than 0 and y greater than 0. So you have to take care of that. Okay. Anything else?
Yeah, ma'am, I have a question.
Oh, yeah, tell.
Yeah, just a general question. So, so since we are doing double integration here, could you please remind us or give us some example where we need to be careful, like we are integrating here. I mean, this function is quite simple. We are integrating like x and then y, but I've seen some cases where we need to be careful with double integration. Do you have any example in mind currently?
Okay, so do you have problem in taking the limits?
No, that I understood. I mean, I'm not able to recall that problem. So I saw some problem where we need to be careful with double integration in terms of integrating
So
your
the
x.
only thing that you have to take care of while doing the double integration is if you are doing the integration first with respect to x, then you will have to treat the other variable as a constant.
Okay.
So that is the only part that you have to take care of, and take the limit properly, upper limit, lower limit, that should be correct. So these are the only things to take care of in double integration, nothing much.
What was the answer, ma'am? B.
So the answer was option B.
B.
Yeah.
Ma'am, one thing. Ma'am, in double integration, we can take the limit first for dx and then dy, and we can also take the reverse thing.
Yeah, right. So there is a form, like there's a theorem in maths that says double integration fxy dx dy same as double integral fxy dy dx. The value will be same, that will obtain in both the integration.
Yeah, ma'am, but suppose if some limit goes to not to the constant but to the variable, suppose x goes from 0, y goes from 0 to 2x. So ma'am, then we should take this part where the integration limit is a variable, not a constant. Then we should take this integration first.
Yeah,
and then we'll take
that you will take care of, like when you have a figure, like when you draw the sketch of the function and draw the support and check your limit. So there, once you do it, so there are questions like that in this solve with this also. So you will see, you'll have to take care of that. So if you are doing first x, then you have to take the limit for x properly. Like it may take like let's say x can take the value limit from 0 to, let's say, y by 2.
Yeah.
Yes. So if you draw the figure, it will be more clear. So in this case, it was quite easy. So we'll see such problems also.
Can I see the answer sheet, ma'am? A, B, B. What was B exactly?
B was answer. E to the power minus 4
Okay,
into
okay.
1 minus e to the power minus 4.
Okay.
Okay.
Okay. Thank you.
Yeah. So let's move to the third part. Okay. So here you have again the joint PDF of two random variables x and y. And for x lying between 0 to 1 and y lying between 0 to 2, your function is defined as 3xy times 1 minus x. Otherwise, it is 0. Now you have to calculate probability x greater than 3 by 4 given y equals half.
A little bit.
Yeah, tell.
This little bit difficult.
Just try it out.
Okay.
Yes, tell. Okay, so let's see the responses. Okay, somebody has answered more than 25. So, okay, that is not possible. The probability cannot go beyond 1. Okay, so please take care of that. Okay, so we had to find probability x greater than 3/4 given y equals half, right? So what we will do here? Can anyone explain?
Here y is constant, so dy equal to 0. The integration will be dx into dy. Shall we increase 0?
Sorry, your voice is not very clear.
Y equal to 1/2 constant.
Huh?
Then dy, the difference in the y will be 0. Shall we assume that dy 0, therefore the total integration will be 0? Answer will be 0.
No, that is wrong. Anybody else?
Yes, ma'am. So we can find first f of y by integrating x, fy
Okay.
integrating x, and we have to put to 1/2. So we'll get the denominator now.
Okay.
For x, in that case, we need to integrate from 0 to 1. And in the numerator, we need to integrate x first from 3/4 to 1 and put y equal to 1/2.
Yeah, that's fine. So what we're using here is like we have to find probability x greater than 3/4 given y equals 2. So we will use our definite formula for conditional probability. Okay, so we can write this as probability x greater than 3/4 comma y equals 1/2 divided by probability y equals 1/2. So we will write this. So once it is done, so we have to find probability. So in this case, we have to find in the denominator part, you have to find fy of half. So how do we find fy? How do we find the marginal of a random variable? We integrate the joint PDF with respect to the other variables. So in this case, we have to find fy of y. So we'll integrate the fxy with respect to dx. So if you integrate with respect to dx, so also you have to take care the limit of x. So x is varying from 0 to 1. Okay, so you'll have to put the limit as 0 to 1 and you have to integrate this function fxy with respect to x. So once you do it, you will get this as y/2. Okay, so fy is coming out to be y/2. So you have to substitute now here y to be 1/2 because we have to find fy of 1/2. So once you do it, you will get fy of y to be fy of 1/2 to be 1/4. Now the question was find probability x greater than 3/4 given y equals 1/2. So in the numerator part, what we will get is find the fx probability that x is greater than 4 in and y is equal to half. So this condition should satisfy. So in the fxy, you'll have to substitute y equals 1/2. So fxy was 3xy 1 minus x. So if you substitute y to be 1/4, you will get 3/4 x times 1 minus x. So you will get 3/4. Okay, so okay, here what we have done is we have taken this fy of half to be on the numerator part. So you will get 4 times fxy x greater than 3/4 comma y equals half. Now we have to fix our y to be 1/2. Okay, so we'll fix our y to be 1/2. So once you do it, you will get 3x/2 into 1 minus x dx. And x is varying from x should be greater than 3/4. So your lower limit of x should be 3/4. And as you see in this problem, so x is the support of x is 0 to 1. So it can go maximum till 1. So x will vary from 3/4 to 1. Okay, so once you
Ma'am,
solve it, yeah,
Ma'am, can you explain from the second step?
this step 4x.
Yeah, ma'am,
Okay.
why 4 came out?
Because the denominator part, that was fi of 1 by 2.
That was 1 by 4. Yeah.
1 by 4. So we have written it as 4 times fxy. So
Okay.
again, you just, so now in the integration part, you will have to substitute y to be 1 by 2. So once you do it, you will get 3x by 2 into 1 minus x dx. So we can take this term out, and you will, once you integrate, so the limit of x is going to be from 3 by 4 to 1, because the support of x was 0 to 1. And here we had to find x to be greater than 3 by 4. So the limit will vary from 3 by 4 to 1. So once you do the integration and substitute the limit, you will get your value to be 5.32. Is it okay?
Ma'am, could you explain how f of y, f of y, the probability?
Sorry, your voice is breaking. Can you repeat? Still not clear.
Ma'am, f of y by 2 is y by 4, right?
Fi of half is 1 by 4.
1 by 4.
Okay, can you write your question in the chat
Ma'am,
box?
am I audible now?
You're audible now. Can you
Ma'am,
repeat?
could you explain how?
Please tell.
Ma'am, I didn't get how you got a problem. Am I audible?
Your voice is breaking in between, so I couldn't hear many things in between.
No, ma'am, he is asking like how he got f of y 1 by 2 is equal to 1 by 4. That portion he wanted to.
Okay. So you have to do fi of y. Okay. So how do you find the marginal probability? So we take the fxy, we take the PDF and integrate it with respect to the other variable. Correct. So in this case, we have to find the marginal density of y. So we'll integrate with respect to x. And so fxy was 3xy into 1 minus x. So we have written it there, and we are integrating this with respect to x. And the support of x was 0 to 1. So the limit is going to be from 0 to 1. So once you do the integration, you will get fi of y to be y upon 2. Okay. And we had to find, in this case, if you look at this formula here, so you have to find probability x greater than 3 by 4 and y equals half divided by probability y equals 1 by 2. So you have to substitute here fi of y to be 1 by 2, right? So we are getting fi of y to be y by 2. So if you substitute y to be half, you will get fy of half as 1 by 4. Is it clear?
Ma'am, here we are keeping y constant.
Yeah, y constant.
In integration, y is constant, and we are taking fy of y. Then we are getting 1 by 4.
1 by 4. Fi of half as 1 by 4.
Yeah, fy of half.
So always keep that in mind. Like if you have to find the marginal of x, then in that case, you will integrate your fxy with respect to y. But if you have to find the marginal of y, you will integrate your fxy with respect to x.
Yes.
Okay.
Thank you.
Ma'am, but y should be integrated from 0 to half, right? How can it be 1, ma'am?
Why 0 to half? It is, see, we are integrating with respect to x. So what is the limit for x? Look at the question. So fxy, it says x is varying from 0 to 1. So why it should be half? Draw the support, make the x-axis, make the y-axis.
Actually,
so
we
x,
need marginal, right?
Yeah.
We need marginal to get the conditional, right?
Yes.
Okay.
So what you have to do is, so x is varying from 0 to 1, y is varying from 0 to 2. So you draw the x-axis, draw the y-axis, draw that strip, that rectangular block. So that in that rectangle, x is varying from 0 to 1 and y is varying from 0 to 2. And you have to find you have to find Fy of y. So if you integrate with respect to x, right? So if you integrate with respect to x, so your x is varying from 0 to 1.
Yes, ma'am.
Right? That is why we are taking the limit as 0 to 1. Is it clear now?
Madam, one more question.
Huh?
If you are calculating Fy of y equal to 0 to 1, 3xy into 1 minus x into dx, madam.
Yeah.
Now the y is constant, correct, ma'am?
Y is constant, right?
Yeah, we can put it y equal to 1 by 2 there itself. Then we can take out the 3 by 2. 3 by 2. Then remaining term you can integrate. It's a very easy number. Why we have to keep the y the continuously until last?
That is not needed. You can there also you can do it. You can put y to be 1 by 2.
Constant means we got substitute 1 by 2, then 3 by 2, then x square minus x, then x cube by 3, then minus x square by 2.
That can be done. Yeah.
1 by 3 minus 1. Same answer we'll get it.
Yeah, same answer we will get. The same.
Is it
process.
okay, madam?
Yeah, that is okay.
Okay. But in the lecture class, we have heard that because of we are confused, when any one variable is constant, then dx or dy will be 0, so the total term will be 0. That's why we are confused. Now we got the clear, madam. Okay, thank you.
Oh, okay. Thank you.
Just a small clarification of my understanding. Like for finding the marginal of y, we have to integrate with respect to x.
Yeah.
And either way for y, right?
Right.
Okay, thank you.
Okay. Okay. Anything else? Can we move to the next question?
Yes, ma'am.
Okay. All right. So this is the fourth question, and it says the amount of milk in liters in a shop at the beginning of any day is a random variable, random amount x, from which a random amount y is sold during that day. So you have at the beginning of any day in the shop, you have x amount of milk in liters, and from there your a random amount y is being sold. Okay, so the joint density of x and y is given to you as fxy equals 2 upon 25, where x is varying from 0 to 5 and y is varying from 0 to x. Now you have to find the probability that amount of milk left at the end of day is less than 2 liters. So please first draw the figure. Please sketch your support and then try to find the probability. That will be easier.
Nikita, just want to check we are connected. You there?
Yes.
Yeah, okay, fine.
Yeah. Yeah, so I've received just 23 responses. Let's wait for 1 more minute and then we'll discuss the solution. Okay.
I missed some part of the last question end. So the answer is 5 by 32, right? For the previous question.
For the previous question, yeah, it's 5 by 32.
Yeah, thank you.
Okay. Okay, let's see the answer. Okay, we have a lot of answers here. Anybody wants to explain this?
The x limit is lesser than 2. They are given less than 2 liter. And y also function of x, because 0 to y less than or equal to less than or equal to x. Then x means here also 2. The limit is 0 to 2, 0 to 2. Then 2 into 2 into 8, 8 by 25. Is it correct now?
No,
X
that
minus
is.
y will be less than 2y.
Yeah, so okay, so here you have to find the probability that amount of milk left at the end of day is less than 2 liter. So what is the amount of milk that is left? So it is given that on a random day, on any day, you have a random amount x, and from that you are selling y amount. Okay, so at the end of the day you will be left with x minus y. So basically you have to find the probability that x minus y is less than 2. All right, so
Yes,
let's see the solution. Okay, so we have a figure here. So first we'll draw the support. So let's see, your x was varying from 0 to 5 and y was varying from 0 to x. So first we are drawing the support. So 0 to 5 is our x and y to x. So this line that you're seeing, OD, sorry. OD, this line that you're seeing, this is y equals x. So x is varying from 0 to 5 and y is varying from 0 to x. So this triangular region OBD is your support. Okay. Now you have to find the probability that x minus y.
This is support for joint PDF.
Yeah, joint PDF.
Yeah.
fxy. Okay. And now you have to find the probability that x minus y is less than 2. Okay. So what we will do is we will draw x minus y equals to 2.
How did this straight line OD became the support?
Because if you
Why?
look at this y,
No, no, yeah.
look here. So in fxy, x is varying from 0 to 5.
Yeah, it is
and
clear.
y is varying from 0 to x. It is clear? Why this triangular region is a support? Is it clear?
This is the standard method to get the support.
Yeah.
To plot.
To plot. Like not the standard method. I mean, you can say the easier method.
Then what is the standard method? We can get the sure shot solution because this is a little bit confusing.
You should draw the figure.
Okay.
So that will be more clear.
Okay.
Okay.
Figure of what?
Figure of whatever is given to you. So here you had x is lying from 0 to 5.
Yeah.
Okay. So first time take on the x-axis, I am plotting 0, 5.
Yeah, yeah.
Okay. And it is given that y is varying from 0 to x. So you should take care that your y should vary from 0 to x. So what we will do is we will plot y equals 0 and y equal x.
Okay.
Okay. So if you plot y equals 0 and y equal x, so what is y equals 0? So y equals 0 is this horizontal line x equals 0.
Yeah.
Right. And what is y equal x? Is this OD line. Correct. This is y equal x.
Yeah.
Okay. So this OD and this x-axis is for y.
Okay.
Okay. And now x is varying from 0 to 5. So we are plotting x equals 0. So this y-axis and x equal 5. You draw the line. So you will see this triangle OBD is the bounded region. Please try to draw it. Like take a pen and paper and please try to draw it. Okay. So this is our support. Now you have to find the probability that x minus y is less than 2. So what you have to do is you have to plot x minus y equal to 2. So this line here AC, this line here is x minus y equal to 2. Okay. So what reason should be x minus y less than 2? The orange reason or the blue reason? Which reason is going to be x minus y less than 2?
Blue region.
Blue region.
Blue region.
Orange.
Orange region.
Orange region.
Orange reason. Yeah. So the orange reason here is going to be x minus y less than 2. Why is that? So here your A is what? A is your 2, right? This point A, this is your 2. So let's take some point here in between OA. So let's take x to be 1 and let's take y to be 0.5. What will get? 1 minus 0.5 is going to be 0.5. So this point here is going to be less than 2. So this orange region basically is your x minus y less than 2. Because any xy you take in this region, your x minus y is going to be less than 2. Just take few points and try to verify it. Okay. So we have to find the probability for this reason. Okay.
Yeah. To find the area of this.
Yeah. So now we have to find the area of like probability of this reason. Okay. So
where did we use this 25 by 2 by 25?
2 by 25. Yeah. So okay. So if you this support, the area is what? This will denote by D. Okay. So that area is 25 by 2.
Yeah, that's 25 by 2. Yes.
And what is the area of this orange region? How will you find it?
25 by 2 minus
ABC.
Minus the
minus
blue
area of
Area of the
triangle of
triangle
ABC.
minus area of the triangle.
Area of
ABC.
triangle ABC. So
Correct,
once you do it, you will get the area for this region OECD.
Yeah.
Okay. So
That is okay.
huh.
Okay.
So the final answer is the blue area, right?
Sorry.
The blue area is the final answer.
No, wait.
No. The orange. You have to find the probability for the orange region.
21 by 25.
Orange, okay.
What did you say?
21 by 25, madam.
No.
25
So okay.
by yeah.
Okay. So we'll find the orange area of the orange region. Can you please
Excuse me, ma'am.
Can you please mute? Yeah, tell.
Ma'am, we can also find this using double integration method.
Yes, we can do it.
Yeah, okay.
So did you find using the double integration method?
Yes, ma'am.
What answer you got?
Ma'am, same 9 by 25 I got.
9 by 25.
Yeah.
16 by 25.
16 by 25 is the right answer.
Maybe, ma'am, I was mistaking somewhere in the limits. Ma'am, what limit should we take in double integration?
Okay, I will come to that part first. Let's see this.
Okay.
Okay, so what we'll do is we'll find the area of this orange region, and then we'll have to divide this by the area of this orange plus blue region. Now, the area of the orange region you can find using this area of triangle OBD minus area of the triangle ABC. So once you find the area of triangle OBD, that is going to be half into base into height. So what is your base? It is going to be 5 and height is also 5. So it is going to be 25 by 2. And what is the area of this blue region? It is half into base. So base is how much? It is 3 and height is again 3. Okay. So half into 3 into 3. So it is going to be 9 upon 2. So we can use this formula here. So area of the region OACDO, that is the orange region, divided by the area of the region OBD. So once you do it, you will get your answer to be 6 upon 25. Sorry, 16 upon 25.
Area of the OBD is the sample space.
OBD is the support. That we got as 25 by 2.
Yeah. It is equivalent to the sample space for this case, right?
Yes, you can say that.
Because this is the method, no, ma'am, to get the probability.
Area of the region.
Everywhere we get the ratio of the cases. So favorable cases by divided by the total.
Right.
So we can say in equivalent to that of the sample space, right?
Yeah, you can say that.
Yeah.
Ma'am, can you move to the previous slide?
Yeah.
Ma'am, how you find this area half into 3 into 3? Ma'am, I think the area should be half into 3 into 3, area of triangle ABC.
Area of triangle ABC, half into base into height. So ABC is what? This A point is 2.
Yeah.
So this AB region is unit 3.
Yeah.
Right. So half into base. And similarly, this BC region is unit 3. So half into 3 into 3. So 9 by 2.
Ma'am, why we are taking this OACD region and we are not taking ABC?
Why we are taking OAC? Because we have to find the probability x minus y less than 2. And this x minus y less than 2 is the orange region.
How?
Okay, so how will you verify this? So let's take any point in x in this orange region. So let's say I'm taking x to be 2 and y to be 1. So you will get 1, right? So
Yeah.
in that case, x minus y, that is 1, is going to be less than 2.
Yeah.
Right? So this orange region, so this is just one point. You can take many different values. Let's say I'm taking x to be 3. Let's take x, I'm taking x to be 3 and y to be, please mute. Please mute. Yeah. So let's say I'm taking x to be 4 and y to be 3. Okay. So in that case, again, it is going to be in the orange region. So any point you take in the orange region, it is going to satisfy the case that x minus y is less than 2.
Okay, ma'am. Okay.
Okay.
Yes, ma'am.
All right. So this is using the area method. Now, how will you find using the integration method? So, okay. So we have to find the probability for this orange region, right? So what is fxy? Fxy is given as 2 upon 25. So you will have to integrate this fxy with respect to x and with respect to y. Let's say I first integrate it with respect to x. So this OD line here is your y equals x. And this AC line here is x minus y equals 2. So what I will do is, for this orange region, I will draw a horizontal strip. Okay. So once I draw the horizontal strip, so you will get, so you will see your x is varying from, if I'm integrating first with respect to x, then I'm drawing a horizontal strip for this orange region. So your x will vary from this y to 2 plus y. All right. And your y should vary from,
what did you tell me?
Yeah, so I am doing first the integration with respect to x.
Yeah. Keeping y constant.
Keeping y constant.
Okay.
So if I am doing the integration first with respect to x, I will draw a horizontal strip in the orange region.
0 to 5. We will integrate from 0 to 5, keeping y constant.
No. I am drawing a horizontal strip, just a horizontal line. Just draw a horizontal line in this orange region. Okay. So this OB line is y equals x and this AC line is x minus y equal to 2. So this x limit will vary from, x is varying from y to 2 plus y.
Exactly.
Okay.
Yes.
So x is varying from y to 2 plus y and your y is varying from 0 to
x.
Not x.
0
you will
to
have
3.
to 0 to 3, right? So this is just for okay. So here you will have to split into 2 parts.
So how the y limit varying from 0 to 3?
Can you do by integration? How will get the answer? Same answer by integration by standard.
No, see, in this case, you'll have to split into 2 areas. So you see the C point here.
Yeah.
So from there, you plot, you draw one line, draw a horizontal line to this x equal y line. Okay. So now you have 2 regions. So let's say this point is E. Actually, it's a little difficult without using pen.
Pen is not there, ma'am, with you. Okay.
Yeah, pen is not there with me.
Okay, ma'am. Forget, ma'am. It is not possible.
Anybody who has done, anybody who has done this, can you present your screen? If you have done using integration.
Ma'am, can you explain the y limit?
So first you'll have to split in 2 parts. Okay. So I will just give you a method. Please try it out. So see, this orange strip OACD you have, right? So what you will have to do is at the point C, you see there are two reasons, like one is CD and other is BC. So
two region of what? Why?
yeah, see, because if you plot a horizontal line from C, like parallel to x-axis, if you plot a line
No,
from
why should I draw a
yeah,
parallel line?
first you draw, like take a pen and draw it.
Okay.
Okay, just do it now.
Okay.
Okay, so if you do it, you will see that for the below region, so let's say that line is going to intersect your OD at point E.
Okay.
Let's mark that point as point E.
E.
Okay.
Okay, ma'am.
Okay. So now if you look at the region OA and CE. Okay. Let's look at OACE. So in that case, if I want to integrate with respect to x first, okay, so my region of integration is going to vary from y to x plus 2. Sorry, y to y plus 2. Right?
This is not clear, ma'am. How?
Okay. So in now you have
0 to.
Just hold on.
Ma'am, for both the cases, the limit of x will vary from y to y plus 2.
No, that is what I'm trying to say. So did you plot what I said? Can you take a pen and do it?
Yeah, ECD.
So now you have OACE.
Yeah.
This is one reason, and you have another reason, ECD.
Yeah.
Okay. So if I integrate this OACE reason with respect to x first, so in that case, my reason of my limit for x is going to vary from x equal y to x equal y plus 2. That is right. Is it clear?
Yes, ma'am. Yes, ma'am.
Y to y plus 2. Now go to the region ECD. Go to the region ECD and sketch a horizontal strip. Now, if I want to integrate first with respect to x? What is going to be the limit? X will vary.
Ma'am, can you repeat what I have to do next?
Now go to the region ECD, and if I want to integrate fxy with respect to x first, what will I do? I will draw a horizontal strip in that region, right? So how is the limit going to vary?
X will be y to 5.
Ma'am, from y to 5.
Y to 5. So that is the difference. So that is why you will have to split this orange region into two areas.
Yeah. Okay, ma'am.
And then do the integration individually and then add it up. You can try this as an exercise and check whether you are getting 16 by 25 as the answer or not.
Ma'am, one thing here. Ma'am, we are done with the x limits, ma'am, but what about the y limits? What should we take?
So for the reason OACE, what should be your y limit? How is y varying?
Ma'am, from 0 to 3.
0 to 3, right?
Yeah.
And in the reason ECD, how is y varying?
Ma'am, 3 to 5.
Yes.
Okay.
So that is what you have to take. Just do it and check whether it matches with 16 by 25 or not.
Okay, ma'am.
Okay.
Yeah.
All right. If it is not clear to everyone, please go back and whatever I have just said, please try to plot the figure and follow the steps. You should be able to do it. Okay. If you couldn't follow now, please do it after the session.
Ma'am, one thing here. Ma'am, before this question, I was taking this thing. Suppose if it is given x is less than y, or y is greater than x, we have to find the probability for y is greater than x. And so y is greater than x means we should shade the area above y equals to x line.
Yes.
Yeah. So, ma'am, for this question, if we are taking x minus y greater than 2, if we take x, we can also write it as x minus 2 is greater than y.
X minus 2 greater than y. Yes, you can write it.
Yeah. So, ma'am, for x minus 2 greater than y, we used to shade the region below the y region, no? Like x minus 2.
So in that case, if x minus y is greater than 2, then this blue region is going to be a required area.
Yeah. So, ma'am, for this case, we are taking x minus y greater than 2. This means x minus 2 greater than y. So this blue region should come for the solution, no?
Yeah, right.
So, ma'am, we are taking orange region here.
We need to find x minus y
less than 2.
Okay, for less than 2. Yeah. Okay.
Okay. Okay, first do the orange part. There is one more method. We can discuss it later.
Okay, ma'am.
Okay. Let's move to the next question.
Ma'am, I had one question.
Yeah.
At the starting of the question, we were discussing that maybe there are two methods. I'm not sure. I'm asking you. So if we have to follow the integration method, then we can start from the question itself. First, we have to draw the diagram, and only then we can integrate.
If it is very clear to you, like what is the area of integration, reason of integration, then you don't have to draw the figure. But to get more clarity of what is the required reason, it is always safer to use like plot the figure and then integrate.
Okay. Okay.
Yeah. Okay. So let's move to the next part. So this question says, so you have the joint PDF given to you, and it is defined as 3 by 2 x5 for x varying from 0 to 2, y varying from 0 to 2, and for x plus y less than equal to 2. Otherwise, it is defined as 0. So you have to check now whether x and y are independent or not.
Excuse me, ma'am. I have a doubt in previous slide. Could you please go back there?
Previous slide.
Yes, ma'am. No, the triangle slide.
Okay.
Yeah, ma'am, this orange reason we divided into two parts. So for the second part, what would be the limit of y?
It is going to be 3 to 5.
Okay, so limit of y should be 3 to 5, and for x?
X should be y to 5.
Y to 5. Ma'am, how y to 5?
Because
y to y plus 2.
Okay, let's no, not 5 plus 2. Okay, first solve the question that I have just given, then we can come back to this. Okay.
Yeah, okay.
Not disturb in between. Okay, so let's look at the responses. So 6 people have answered yes and 18 have answered no. Okay. So how to check whether x and y are independent or not?
First, we have to calculate the marginal PDF of fx and fy. If fx into fy will result into fxy, then it would be independent. Otherwise, not.
Yeah, right. So, okay. So first thing that you have to do here is again try to plot the support. So, okay, the figure is not provided here. So how will you draw the support? X is varying from 0 to 2. So you will plot x equals 0 and x equal 2. So your x is varying from 0 to 2. So this horizontal strip from x equals 0 to x equal to 2 is your x reason. Now y is varying from 0 to 2. So you will sketch y equals 0 and y equals 2. So the horizontal strip y equals 0 and y equals 2 is going to be your y reason. So this rectangular reason is 0 to 2 and y to 2. Okay, so this square you will get.
Any figure?
Sorry?
Sharing any figure, ma'am?
No, I'm not sharing any figure. I'm just explaining. And if you plot x plus y less than equal to 2, so for that, what you will do is you will plot x plus y equals to 2. Okay, so this is going to be the triangular reason.
That's a diagonal one.
Yeah, the diagonal one. Yeah. So, okay, so x plus y should be less than 2. So it should be to the axis side. So you will get a triangular reason, and this is your support. That is going to be a support.
Is the bottom diagonal.
Bottom diagonal, yes, right. So now we have to find fx and fy. So what is fx? Fx is integral of fxy with respect to y. Now we have to find the reason of integration for y. So what we will do, we will draw a vertical strip in that support. So if you draw a vertical strip on that support, you will see that your y is varying from 0 to 2 minus x, right? Your y is varying from 0 to 2 minus x. So once you integrate this, so you will have to keep your y to be constant. Sorry, x to be constant here. So if you put x to be constant and integrate with respect to y, where the limit of y is varying from 0 to 2 minus x, you will get fx of x to be 3 by 4 times x into 2 minus x whole square. Is this part clear?
Yes, ma'am.
Okay. So similarly,
Why are we keeping x as constant?
Because we are integrating with respect to y.
A function is in x. And
function is in both x and y. But we are
inside you are given as an x only, no?
Yeah, it is x only. At the end, you are getting it in terms of x, right? The final, look at the final answer. That function is with respect to x. The variable there is x. Right? That is a function of x. That is okay. So if we are integrating, so we are integrating your fxy. That is a function of two random variable x and y. So whenever we have to find marginal of x, we integrate your fxy with respect to the other variable. So in this case, the other variable is y. So we are integrating your fxy with respect to y. So we will have to keep the variable x as a constant, because we are integrating with respect to y. Y is a variable. And we are putting the limit for y, that is 0 from 2 minus x.
Not able to physically relate the equation.
Okay. See, whenever you have to find the marginal. Okay. So if we have to find the marginal of x, what do you do? Can you tell me?
I didn't get the question properly.
So if I'm asking, if you have to find the marginal density of x, you have a function of two random variable x and y, and you have to find the marginal density of x. How do you find the marginal density of x?
By solving for y.
Solving for y, right? Yeah. So in case of discrete random variable, let's say this was continuous case. If it was a discrete case, then in that case, what you do is you sum it, you write your fxy, whatever the function of your two random variable is, you write your fxy and you sum it over all the y values.
So
whenever you draw the table, right? Whenever you draw the table for the discrete distribution, the joint the joint distribution table, whenever you draw it, and if you have to find the marginal of x, you sum it over y, right?
Right.
So this integration is nothing but summation in continuous case.
Okay, it is just a replacement for the summation in the continuous case. Okay.
Yeah. So we are again integrating. So in here we are doing the integration. So we are integrating with respect to y.
Okay.
And since we are integrating with respect to y, we have to look for the limit of y. So the y is varying from 0 to 2 minus x. So why we are saying it is fx of x? Because see, at the end, you are getting the function, your fx in terms of the variable x.
Okay.
Okay. So
but I'm not able to connect that one to the figure what you are telling, 2 by 2 square, and we put up a rectangle, and we put up a diagonal.
The lower diagonal, yeah.
And the lower triangle is the required area.
Yeah, right.
But is that the one corresponding to this equation?
Yes, because that reason is x, that diagonal line is x plus y equals to 2. And now if you have to find the limit of y, what we are doing is we are drawing a vertical strip in that support. Okay, so if you draw the vertical strip, you will see your y is varying from 0 to 2 minus x.
0 to 2 minus x.
0 to 2 minus x. That line is x plus y equal to 2.
Okay, the diagonal is right, x plus y is equal to 2. So the y value varies from 0 to
2 minus x.
2 minus x, right?
Right.
So that is what it is here. Okay. Now, but 0 to 2 minus x. Okay.
So you just have to do the integration now.
Got it. Thank you. Thank you, ma'am.
Okay, thank you. So similarly, we will find fy of y. So once you do it, so to find fy of y, you will have to integrate your fxy with respect to x. So similarly, to find the limit for x, what you will do is you will sketch a horizontal strip in that support. So once you do it, your x will vary from 0 to 2 minus y. So you will get fy to be 3 by 4 times y, 2 minus y whole square. Okay, so we have got your fx to be 3 by 4 x times 2 minus x whole square, and we got our fy of y to be 3 by 4 y 2 minus y whole square. So if you multiply fx and fy, you are not going to get 3 by 2 xy. So since fxy is not equal to fx times fy, we can say that x and y are not independent. So our correct answer is no.
Ma'am, do we have such type of functions where fxy is independent?
Yes, we have. You can see in your activity problems.
And can we really not conclude just because the equation x plus y is less than or equal to 2 obviously makes that they are dependent, is it?
Yeah, by intersection it is visible that it is dependent. Because one
can I not
no.
draw the conclusion like that?
No, drawing conclusion like that may not be correct.
Okay.
So
function,
what we are going to do is we are going to have a session for week 5 where you can see the visualization for the function of 2 random variables.
Okay.
So once you do it, maybe it will help you to see it properly. So we are going to have one session on that for visualization of 2 random variables.
Yeah, it is required. Some little bit confusing.
Yeah.
And can you show the second page where
yeah
the equation? Yeah, just.
Ma'am, I have a doubt. So for question number 3, we haven't drawn any strips to calculate the marginal for y. Why we are doing that for here?
Question number question 3. Why is that? Because it is properly given that x is varying from 0 to 1 and y is varying from 0 to 2, right? So if we find fy of y, you are doing the integration with respect to x, right? So in that case, it was clearly given that x is varying from 0 to 1 and y is varying from 0 to 2. So this is this triangular region where your x is from 0 to 1 and y is from 0 to 2. This rectangular region you have. So if you draw a horizontal strip, okay, we are integrating with respect to x. Draw a horizontal strip. What will you get? What is the limit of x?
Okay, now I got it. So
you got
the
it?
earlier one was rectangle. So it
there
was uniform.
you had a function of x and y, so that is why we had to take 2 minus x and 2 minus y.
Okay, thank you.
Okay. Okay, so this is our last question. So it says a person randomly chooses a battery from store which has 30 batteries of type A and 70 batteries of type B. And battery life of type A and type B batteries are exponentially distributed with average life of 3 and 7 years. If the chosen battery lasts for 5 years, what is the probability that battery is of type A? So in this case, you have both continuous and discrete distribution. So yeah, let's solve this. Please do the calculation properly. Do it carefully. There's a high chance you miss some part. Okay. Okay, let's see the solution. So many people have answered option C. Okay. Sorry, I lost my connection. Okay. So I was asking if anybody can explain how they have answered option C. Am I audible?
Yes, ma'am, you are.
Yes.
Yes,
Yeah. So anybody wants to explain how they got option C? Okay, let's see the solution then. So what all information do we have? So first it says there is a store and a person randomly chooses a battery from that store that had two types of battery. One is of type A and other is of type B. So we have total of 30 batteries of type A and a total of 70 batteries of type B. So the battery life of type A and type B are given to be exponentially distributed. So what is given to us is, given that you have a battery of type 1, what is the battery life of type A? What is the battery? What are the battery lives? So that distribution is exponentially distributed with average life of 3 years. And given that you have a battery of type 2, that their battery life is exponentially distributed with an average life of 7 years. So if the chosen battery lasts for 5 years, what is the probability that the battery is of type A? Now you choose a battery and you see, you find out that this battery lasts for 5 years. So what is the probability that this battery is type A? So basically, if I take a random variable, let's say X, to be discrete, where X says it is taking the value 0, if battery is coming from type A, and it is taking the value 0, 1 if it is coming from type B, then it is discrete. So we have to find the probability batteries of type A. So what is the probability that X is coming from, if A is taking the value 1, then what is the probability that X equal 1 given the battery life is 5 years, right? So let's denote that random variable. Let's denote y denote the so let's denote the battery life by the random variable y. Okay, so given the battery is from type A, so we have defined our X in such a way that if the battery is of type A, we'll call it we'll give it 1, and the batteries of type B is value 0. So when X is 1, the distribution of y is going to be exponentially distributed with average life of 3 years. So why we are writing the parameter here as 1 by 3? why we're writing the parameter here as 1 by 3? Because in case of exponential distribution, your mean is 1 upon lambda. So if some random variable has the distribution, let's say has some distribution exponential lambda, then the mean of that distribution is going to be 1 upon lambda. So if the mean is given to you as 3, it means the parameter is going to be 1 upon 3. So in this case, lambda is 1 upon 3. Similarly, if the battery is coming from type 2, it means given x equals 0, the distribution of y given x equals 0 is given to us as exponential 1 upon 7. Now we have to find what is the probability that x equal 1 given y equal 50, y equal 5, right? So this is what we have to find. Okay, to find f x given y equal 5 of 1. So we'll use the formula for conditional distribution again. So in the numerator part, we can write fxy of 1 comma 5 divided by fy of 5. Okay, now in the numerator, we can write we have written probability x equal 1, y equals 5. That can also be written as fy given x equal 1 times 5 into probability x equal 1. Is the step clear to everyone? The numerator part.
Yes, this is very much similar to base rule, right?
Base rule, yeah.
Yeah, yes, ma'am.
So this is just nothing but the base rule. So now we have to find f of 5 given x equal 1 of 5 and fy of 5 and x equal 1. So x equal 1 is so let's say how do you find x equal 1? So it says what is the probability that your battery is of type A. So you have a total of 30 plus 70 batteries. So what is the probability that the battery is of type A? It is 30 upon 100. Then again, what is the probability that your battery is of type B? It is 70 by 100, right? So we had to find a probability x equal 1. So that is going to be 30 upon 100. So that is 3 by 10. So this part is done. Now we have to find fy of y given x equal 1 of 5. So y given x equal 1, we know that this follows the distribution exponential 1 upon 3. So what is the PDF of exponential 1 by 3? It is lambda e to the power minus lambda x. So in this case, lambda is 1 upon 3. So we'll write 1 upon 3 e to the power minus 1 by 3 x. So we have to find this for 5. So that y is going to be 5. So we will write 1 by 3 e to the power minus 5 by 3. Okay. So this is going to be 1 upon 3 to the power minus 5 by 3 into 3 upon 10. This is the numerator part. Now, how do we find fy of 5? So fy of 5 means what is the probability that your battery lasts for 5 years? So here you have two different possibilities. The first is your battery is coming from type A and it lasts for 5 years. And the second is your battery is coming from type B and it lasts for 5 years. So we can write, again, we can use the law of total probability here. And we'll say fy given x equal 1 of 5 into probability x equal 1 plus fy given x equal 0, 5 into probability that x equals 0. So same way we can find, the same way we have found this numerator term, we can find this fy given x equals 0 into 5 into probability x equals 0. And we can just substitute these values and add it up. So once you do it, you will get the final answer as 1 upon 1 plus e to the power 30 upon 20 upon 21. So many of you have answered option C. Why is that? Where did you go wrong? How did you get option 3? Anyone?
Ma'am, I forgot to multiply the 3 by 10. the
Okay,
probability
always.
vector is equal to 1.
Okay.
And
Okay.
I kind of figured the one where the probability, there's an exponential probability of 5 by 7 was the right answer. That's why I went for that.
Okay.
I got confused in the process itself, so I chose the answer that looks similar to what I was doing.
Yeah, right. Okay. So this part is clear. This question is clear.
Yes, ma'am.
Yes, ma'am.
Okay. So this was our last problem. Yeah. So okay. So if you have no doubt from this these slides, can we?
Ma'am, I have still doubt in that triangular part.
Okay. Okay. Let's go back there. So yeah, where is the doubt? This upper triangle, right?
Yes, ma'am.
So if you okay, that point we had taken to be E. So if you look at the triangle ECD and you take the limit for X, what is the limit? What is the lower limit for X? What is the lower limit?
That should
for
be
X?
3.
Why is it 3? Okay, so if I am integrating first with respect to X, what will I do? If I am integrating fxy with respect to X first, what will I do? What should be my first step?
Now I should first find the limit of X, right?
Yeah. So so what you should do is, like, whenever you have to integrate first with respect to X, first, in this case, the support is going to be ECD. The reason is ECD. Okay.
Yeah.
So whatever your reason of integration is, what you will do is, you will, if you have to integrate first with respect to X, you draw a horizontal strip in that region. So in the triangle ECD, in this case, you draw a horizontal strip in that triangle. So once you draw the horizontal strip, where is the X starting from? X is starting from this line, ED, right? X is starting from that line, ED. Correct?
Now ED is a diagonal line, right?
Yeah, the diagonal line. So if you draw the horizontal strip in that region, ECD, in the triangular region, you draw a horizontal strip parallel to X-axis.
Yeah.
Okay. So once you draw a horizontal strip parallel to X-axis, from where is your X starting from? Where is your X starting from? You draw a horizontal strip. What point it's touching, like X? It's touching this diagonal line ED, right?
Yeah, right. It's starting from the diagonal line ED, right?
ED. So that, what is the equation of that line?
That is X equals to Y.
X equals Y. And what do we have to find? We
Limit
have to
of
find
X.
X.
So yeah, the lower
X
limit
will
will be
vary
X.
from,
Yeah.
lower limit will be Y.
Yeah. Lower limit will be Y, right?
And if you draw the horizontal strip to X-axis, so what should be your upper limit?
Okay, that should be 5.
That should be 5.
Right.
Right?
Got it. Thank you.
Got it. Okay.
Ma'am, if we do the same thing with a vertical strip,
that will also work. So if you want to integrate first with respect to Y, then you draw a vertical strip parallel to Y-axis, and then check, put the limit properly, and then integrate.
Yeah. Okay, ma'am.
You can practice more and more problems to get the clarity.
Yeah, it's tough to visualize, ma'am, actually, this method.
Yeah, so but if you like sketch the figure and just do it, it is not so difficult actually. You should just know the method. So like first draw the reason. What is the reason of integration? If you want to integrate first with respect to x, you plot a horizontal strip with parallel to x-axis and check the limit for x. Check the lower limit, check the upper limit. Again, you do the same thing for y. So you have a lot of problems in activity tutorials. Just go back and try to, don't look at the, in activity don't have the solution, but even in tutorials, if you do it, don't look at the solution first, look at the problem, try to do it on your own first, and just see how everything is solved later on.
Yeah.
Okay.
Ma'am, am I audible?
Yeah, you're audible.
Ma'am, so a small doubt, ma'am. This is with respect to limits. So I'm just asking generally, ma'am. So we generally have some say problem. So we have x from 0 to 50, some random distribution, ma'am. And we have y. Y is like it is from 0 to x.
Okay.
So for integrating these kind of problem, I will tell my thing, ma'am, what I had understood and what I have done.
Okay.
So you just tell me if the approach is correct, ma'am.
Okay.
So
Okay.
the thing what I would do is, so I would integrate y from 0 to whatever given x value.
You will integrate
so I would
y
maintain,
with... Okay. So are you integrating first with respect to x?
No, with respect to y, I am integrating.
With respect to y. Okay. So what is your lower limit here?
So the lower limit will be the, take 0, ma'am, example, say 0.
In this, whatever example you have given, according to that, it should be 0.
Yeah, 0. So
And
the upper limit would be y minus, say, upper limit would be in this particular example, ma'am, the upper limit would be x minus 2.
Okay, are you taking x? Okay, I thought you have taken y equal x. Okay. So
yeah, I'm just seeing this and telling, ma'am. So x minus y equal to 2. So y is x minus 2. Correct, no, ma'am?
Y equals x minus 2. Correct.
Okay. But in the x-axis, when you come to x-axis, what you have to submit is you have to take the lower limit as 0. But the upper limit is, since it is dependent, since it is lesser than say x, we have to take the maximum x value you can get. We have to substitute the y value.
So if you are looking at this triangle ABC, okay, and if I'm integrating first with respect to y, I am drawing a vertical strip parallel to y-axis. And in that case, our limit for y is going to be from 0 to 2 plus x. Sorry, x minus 2. Right? And if we have to integrate again that with respect to x, then in this, the same reason, we will, in the same triangle ABC, we will draw a horizontal strip parallel to x-axis. Then in that case, your x is varying from 2 plus y. 2 plus y to 5. You have to look at the curve. So the curve is x minus y equals to 2.
Okay, ma'am. So, ma'am, so ma'am, the example what I was trying to ask is, so you have 0 to 50 x, ma'am, and y is strictly lesser than x.
Y is strictly lesser than x. Okay.
Not strictly, lesser than or equal to x.
Okay.
So in this case, you would take, if you do the same thing, it would be 0 to say 1 minus x.
Why are you taking again 1 minus? You told y is less than equal to x.
Yes, ma'am. Sorry, ma'am. I'm really sorry. So it is the higher limit is 0 to 50. Yeah. So it is 50 minus x. Sorry, ma'am. I'm sorry.
Why is it 50 minus x? You are saying x is taking the value from 0 to 50. So on the x-axis, I am plotting the point 0 to 50. And you are saying your y is less than equal to x. So I will plot y is less than equal to x. And that is going to be my triangular region. Right? The lower triangular region. So if I want to integrate this with respect to x, with respect to y first, right? So in this case, my region of limit is going to be from y is varying from 0 to x, right? Because it is y equal x. Right? Okay. Is it clear?
Okay, ma'am. Okay. So yeah, my assumption, I think it's correct, ma'am, almost. So you may take it, I mean, if I do it the other way, it's like 50 minus x, but you have to correspondingly give the correct x value. That's the final funda.
Yes. Yeah.
Okay, ma'am. Thank you, ma'am.
Okay. Okay. Anything else?
Excuse me, ma'am.
Yeah.
Ma'am, you were saying that you are going to discuss question number 9 in detail of activity 5.3.
Yes, right.
Yeah, okay.
Okay, so I will tell to stop the live streaming.
Ma'am, if you can put the double integral here and connect the chart to the integrals.
Sorry.
If you put the double integral in the same page and connect the limits to the integrals, probably the chart will be more clear. You can write it, is it?
Sorry, I did not get your what you're trying to explain.
If we put the double integral, that equation, and connect the limits of both the integral to the chart.
Okay.
Particularly OA and BC and CD and BA. Because the integral has 4 limits.
Actually it's suggesting to provide the alternate method. So you have provide the solution using area method, right?
Okay.
Yeah, that area method, if you really connect to the graph, probably it gives a better explanation.
Yeah, so I have explained it orally, like I have to get my pen fixed. Okay. So yeah, the other method also can be done. I've explained it. Like if you can go back and just listen whatever I have said and just follow it and try to do it, you should get the answer. Please try to do it. I will also try to give the solution for the other method in the slide when I upload it.
Okay.
Yeah. Okay, so if there is no doubt from the slides, you can leave out now. Okay. You can leave the session. So I will just explain one more problem somebody had asked.
You explained a website, for the books at the start of the session.
Yes. Somebody has posted it on the chat box. Can you take it from there? It is Libgen. It is LIBGEN.
LIBGEN.
LIBGEN. I will type it on the chat box. You can search it. So you can go to this website and you can find many books there.
Thank you.
Okay, thank you. Okay, so all of you who doesn't have any doubt from the slide, you can please drop off.
Thank you. Thank you.
Yeah, thank you so much. Yeah.
Thank you, ma'am.
Yeah, thank you. Okay, so can you tell me what question was that? It was question number.
Question number 9.
From 5.3 question number 9.
Yeah.
Okay, yeah. Can you tell me